Hello everybody, we're going to be working on our Chapter 39 exercises tonight, and we have two of them to work on. The first one I think is a fairly simplistic one, but the second one is a little bit more involved, and I expect that we'll probably be working on these probably for the entirety of the night. If by some miracle we finish them quickly, we'll try to move on to the next chapter. We'll see where we're at when as we get rolling here. Alright, so just to kind of do a little bit of a recap of where we were at in our text, we were working on example problems that are loaded into the chapter for Chapter 39. And unlike some semesters, I didn't actually get to the point at the end of the chapter where they do a sample database exercise. So if you want to get a sample where they have the student registration form, you guys can actually go to that particular exercise and step through it. They give you all the code, and it's a pretty fun little thing to do. And the reason it's important, frankly, is because when it comes to building the actual homework for 39.9, is really, really similar to what is in that exercise. It's just tweaks and database changes mostly. All right, let's go ahead and get started with the first exercise. I already have the PDF up on my screen here, and I'm going to go ahead and read this here in just a moment. All right, so it says here, the exercise is called Factorial table in JSF, and it says write a JSF page that displays a factorial page as shown in figure 39.27. So like this, so you're going to create a HTML table, pretty basic to do, but you have to get it to do the math. All right, so that's kind of the tricky part here. Display the table in an H output text component. So they don't want you just to use an HTML table. They want you to use that particular thing. And set its escape property to false to display it as HTML content. So we're going to step through this one piece at a time, but I have to ask you, I assume most of you aren't here at Gateway because you're math majors, right? Probably not. But you know what? You do need to kind of figure out what a factorial is before you can actually create one. So let's actually jump out to the internet really quick and type factorial. And let's read what it says. It says, in mathematics, the factorial of a positive integer, n, is denoted by n exclamation. So that's how it's like mathematically declared. It is the product of all positive integers less than or equal to n. For example, the value of 0 factorial is 1. Okay. In fact, let's just go to the Wikipedia thing here and see really what we're trying to create is this table, right? But the math for it is this. So the formula for n factorial is this. You multiply n and then in a sequence times the next number in the sequence minus 1 times the next number in the sequence minus 2, etc., etc., etc. And what ends up happening then is if I put in 5 factorial, I start with 5 times 4 times 3 times 2 times 1, and it equals 120. They do tell you that one of the rules of it is if you're trying to get the factorial of 0, it comes out to 1. Why? That's just the rule. Okay, there's no other way to really explain it. The factorial of 1 times 1 obviously is going to be 1. All right, so those are kind of the oddities. But from there on in, all the other math will completely make sense. And so what's fascinating about this is really an interesting thing, because when you look at mathematics, a lot of the stuff we do in mathematics is really kind of based on being able to designate what you're trying to do in some sort of a notation. So in other words, in math, they have systems for displaying equations and certain formulas that, until, frankly, you get to the upper echelons of math, you often don't really understand what those mean. The factorial is a special value, and I'm wondering if they have, there we go. So this is what I'm looking for. So this is n factorial, and this is how it would be defined in terms of like how you actually accomplish it. However, if you were studying calculus, and I don't think anybody here at Gateway studies calculus except for engineering students, and then probably reluctantly so, they actually do have a notation in calculus that indicates how to do this. The funny thing about calculus is it's not a singular formula. So like when you look at like an algebraic equation, often you'll have, for example, some notation that says the function of x is, x plus 3 or something like that, right? And what they're really trying to tell you is how you solve it. So you can plug in to the x, with the x kind of being a variable. So if you think about that in terms of math, right, kind of correlates to programming. The thing is when you have a repeating function, then you have to display it over a range. And what this indicator shows you, if you learn calculus notation, is it shows you that like when you have this giant letter P in a calculus thing, it indicates product. And then if you have a capital, and yeah, you guys don't know that as PC. I speak Greek, so that's a letter P to me. That's a capital P in Greek, which stands for product. Isn't that interesting? Yeah. And then if you were doing a collection of sums over a range, you would use a sigma, which looks kind of like a backwards E, and they have all these symbols. And then all the little things that surround it indicate like what values you're pumping into it and how to evaluate it. So once you learn that notation, it gets kind of fascinating. So anyhow, whether or not you understand the equation, if you start to read through it, you start to realize that there's kind of this thing called recursion happening, right? So when you're kind of like feeding the formula onto itself, which is about what we're about to do, the way that we solve it in computer code is we create a method to run the math that in turn calls itself to run the math, because and as you kind of like keep calling yourself, you kind of step through this, and I'll show you that in code. And I don't expect you guys to like intuitively understand how to convert from what you might read out on the web to computer factorial and convert it to a formula, which is one of the reasons why I help you do the exercise. However, I know that you can probably just type in a Google search that says Java code for computing factorial, and you'll find it. And you know what? I'm okay with you copying it, frankly. I'm not here to teach you math, and I could spend like a whole night just teaching this and explaining it. So I'm fine with that. The more important part is to write the code and then have it tie into a web application that feeds it to the front end and creates that table correctly. So that's what we're about to do. So let's think about where we're going to start to do this work. So in terms of creating an actual application that does this, I'm going to say that please go ahead and create a new project inside of NetBeans. Yes, we are using NetBeans, and we're going to follow the same approach we've been using for all the JSF applications. So we're going to choose Java Web and Web Application, and then click Next. Now I'm going to go ahead and call this exercise 39_1. That just seems to make sense to me. I'm putting them in a 2019 folder. That's fine too. I'll go ahead and say Next. And then it asks us which web server we're using. Of course, we're going to use Glassfish and the latest possible version of the Java EE for web. You can leave the context path alone. That's just fine. Let's go with the defaults. And then, of course, we are using Java server faces here. I did click it, and I don't know if you guys are having the same issue. And this happened to me last time. It was really slow in responding. There it is. Yeah, a little sluggish, but you know what? We'll be patient and make it work. All right. There's no other selections we really need to make here. So once you have that selected, go ahead and click Finish, and then this will build out our project folder, including an index.html. Now, let's just talk about what it's going to take to actually display this on the screen. First of all, we're going to use the index page. We don't really need to create a secondary one in this case. So I'm just going to call this Factorials, or maybe like this, JSF Factorials. Like so. I'm going to get rid of the text in the body section, and then I'm going to do what the book said. Well, first of all, I want to kind of display it like the book has it, and the way the book has it looks like they have some sort of a title or a heading tag here, and then they do their table. So I'm going to begin by, I think I'm going to go with an H2. So I'm going to create an H2 here, and I'm going to say display factorials. And the H2 selection is highly subjective. Could I use the H tags to create this? Yeah, I could, but who cares really, to be really frank. On the secondary part of it, though, they were pretty specific. When you create that table, that they do want you to go into a very specific structure, and that's because this structure allows you to feed the Java code back into it from the external file. And what they want you to use is that H tag, and we're going to choose output text as our format. The next thing we're going to do is they asked us to put an escape attribute in, and that escape attribute should be set to false. Next, we also want to populate the table with something, and the way we're going to do it is by calling an external file that's going to provide the value that's going to go in there. However, right now, I don't have anything to put in there, but I am going to put something here. Okay? So I'm just kind of leaving it like that for now. So once we have the second part created, the Java code, then we will know what it's named and what methods we have inside that we're going to call, and then we'll include it here with the hashtag and the curly brackets, and then it will call that external file. The file will generate whatever, send it back into the spot, and it'll put it in an output table just the way we need it. All right. So if you've gotten this far, go ahead and click S to save. So now we have that saved. The next step here is going to be to go ahead and create a managed bean to go in this project. So I'm going to right click and I'm going to choose new. And since I've done this before, and in fact that's the most recent action I've done with the right click in here, it's right up at the top. If it is not, you have to go to other and hunt through to find it. And I think we demonstrated that last week enough where you guys should be okay with it. So I'm going to choose JSF managed bean, and then the screen is going to pop up. I'm going to go ahead and call my class name compute. In fact, I'm going to start it with a capital C, Factorial. I'm going to change out of that field. You could put in a package declaration if you wish. Frankly, I'm not really worried about it, even if you leave it blank. It is, not making NetBeans happy if we avoid that. So if you really want to put in a package declaration, go ahead. And you can call it whatever the heck you want. You can call it exercise 39.1. You can call it, why don't we do this? Let's just call it exercise 39.1, just to give it a name. Oh, and it's telling me it's not valid. It doesn't like the dash. Does it like the underscore? Yep. So we're going. That's why we use underscores, by the way. The next thing that we have to do is come down here and notice that it gives us a camel case version of the class name. And then it's also asking us for the scope of the project. And for right now, since we're not really doing a lot of interaction and stuff, we're just going to choose request, which means it's going to request information from the external file and pull it back. So let's just choose request, and then we can go ahead and click finish. That's going to go ahead and build a Java file for us, and you can see it's up on the screen already, with the package name and some pre-configured content, including an attribute for alternate way to call it. It also will indicate the request scope, creates a constructor function for us, and that's really kind of about it. Now, this isn't going to be a class that we're going to instantiate. So I'm not going to call this to create an object that we then manipulate further. So I'm actually going to get rid of the constructor. Let's just get rid of that and save the screen space. I'm also, and you don't have to do this, I'm getting rid of all the unnecessary comments in here too. And my thinking is that maybe I can get fortunate enough here to squeeze it all on one screen. so you guys don't have to scroll to get the code. Okay. Now, before I can create any of the output elements, so we're going to kind of talk about these in kind of pieces here. I do want to figure out how to do the math part first. And I'm going to actually create two methods inside here. So one method is going to be the method that builds the HTML and sends it back to the HTML page. And if you're thinking about this carefully, we're going to have to do math. Every time we're going to generate a row in this table, we're going to have to feed numbers in and then do the math, build a row, send the number over, do the math, build a row, and we're going to repeat that process over and over. But we do need to do the math at some point. So first we're going to write the method inside here that's going to do the math for us. All right. So I'm going to create this as a private. Could I create it as a public? Sure. If you want, you can totally do that. I am going to set it so that it returns a long. And what that is just an integer type that allows for numbers that are greater than whatever the limit of an integer is. And I think it's like, I forget if it's like 2 billion or 2 trillion or something like that. But if you happened to run this program more than 10 times, in the book they run it 10 times. But if you wanted to run it 20 or 30 times, the numbers get exponentially larger as you go. And I just don't want you to overrun the capability of the data type, so that's why I'm using a long. Now, the way that we're going to operate this is we are going to pass values to it. And what are we passing? We're going to pass integers. And you know what? Let's use n as the variable name inside the method. So we'll create a curly brackets. And then, and I'm giving you the code to do this, but I'm going to talk through it as I do it so you understand the procedure. Just really quickly going back to Wikipedia, if 0 is really the only anomalous number here, right? Because you can't multiply. Okay, so if you only have one number, you feed in a 0, it should be 0, right? But for whatever reason, they start at 1. And I think that the reason they start at 1 is to allow it to do other types of mathematical operations, and it's just a rule of the format. So if a user types in or just enters a 0, and it's only going to run 0 times, we're gonna feed a 1 back. So what I'm going to do here is I'm going to start with an if statement and say exactly that. I'm going to say if n is equivalent to 0, curlies, just return 1, just like that. We don't have to do any math. There's no guessing here. There's no math that has to happen. We just return 1 because that's what it is. Right. And then yes, correct. We will do an else, and we don't have to have an if at this point. We'll just run an else. Another set of curlies. And yes, I could actually, folks, I don't even need to put this inside of curlies or really on a separate line. I just do that because for me it's easier to look at, right? But then we do the math. Now here's the beauty of this. To return a factorial, once again I'm going to refer to that Wikipedia page, and they give you some examples here that are kind of interesting. So what they do in this part here, they're demonstrating to you the fact that if you're trying to get the factorial of any number, you're going to take the number you typed in times the next number down factorial. See what I mean? So if you're doing 5, I mean, if you're looking at like the original way to do it, it's like 5 times 4 times 3 times 2 times 1, right? Yeah. But really that's equivalent to 5 times 4 factorial. Right. So wait a second. So I'm going to multiply the number that I have in there by the product of factorial. Yeah, so this is where the recursion comes in. So what they're saying is for each subsequent number, you're really computing it against that subsequent number's factorial. Kind of an interesting number sequence in that capacity. So the way that I would express this in a computer program is like this. I would multiply n times Yeah, so I'm going to take that n minus 1 and feed it back onto itself. Isn't that weird? It's really not that weird. No. But this is probably the first time maybe in your in your computing experience that you guys are encountering what we call recursion. So recursion in computer programming is when you use a method to call itself. Now you got to be really careful with that because you can get stuck in scenarios where you create infinite loops even though it's not a loop. You know? And frankly what's really interesting about this stuff is when you look at mathematics and the simplistic things they're really trying to describe, because if you say to somebody, well, n factorial is give me a number, and that means every number that is smaller than it multiplied onto it. I mean, that's kind of easy to understand. But in terms of the procedure to get there, that's not quite as simple. However, the wonderful thing about mathematics is really close to nature. It's really kind of like a brute force way to try to explain the elegance of nature. Right, because if you start looking at like what nature does naturally when it like creates like DNA or plants grow or weird things like that, a lot of that kind of recursion happens in the replication of DNA. And Nathan, that's a really good and astute call. You know, how does DNA replicate itself? By replicating itself, you know. So it creates itself by creating itself, you know, and recursion is kind of a way to say that. All right, so that's really all of the math. There's nothing more to it than that. If it helps make it easier for you to read, you can always do this. And you know, usually when I teach programming, I separate everything out so that's a little easier to read. But now we need to do the part of the of this Java file that's actually going to write the HTML. And as it writes the HTML, it's also going to call the math for each separate row. So if you're thinking like I'm thinking, for each row of the table, to me it seems we're going to be looping here. And so that's exactly what we're going to do. First, let's create a new method. And I'm going to call this one, and notice how I'm making this a public one, because this one's going to be called from the outside world. We don't want the web application calling the math part directly. We want only the internal part of this program to do that. And here we're going to put our get response method. And that's just kind of a commonality. It doesn't have to be called that, but that's kind of convention in Java. All right. Now, for all the HTML that we're going to start building, I'm going to actually start expressing the HTML as a series of strings, and then I'm going to take all that HTML and put it in one variable as I go. So watch how I do this. First, let's declare the variable. I'm just going to declare a string. I'm going to give it the name S, just simply because it's efficient. And then I'm going to go ahead and start writing inside of my Java code, inside of a variable, the HTML that I would use if I was creating it on the web page. So this is kind of weird, right? So I'm going to go ahead and start by creating a table. Okay, so I'm going to put in the beginning of a table tag, except I forgot the opening bracket, didn't I? All right, so there's the opening bracket. And I noticed that from the listing that they have in the document, that table does have a border, and I'm not really a huge fan of borders on tables, but you know what, that's what the book's doing. And normally you would type something like this. You'd say border equals 1, and then close your tag. Except HTML5, and XHTML, which has really strict rules, you must have that stuff in double quotes. Uh-oh, we have a problem, Houston, right? Yeah, you can't put double quotes inside of double quotes, so you're going to have to put escape characters in front of each one of these double quotes. Yeah, just to make it appear. Now, I could keep typing all the rest of the HTML on one line, right? But the way that my brain thinks is it's a little bit easier if I kind of separate it out. And you know, I put in a semicolon, partially because it was squawking at me. But really what's going to be better here is I'm actually going to put it in a concatenation symbol and just move to the next line. So instead of like worrying about like how I'm formatting my HTML. I'm kind of doing it just like I would with my HTML, but I'm putting a plus sign in between each line so that it reads it as part of a continuous string. So once I have a table formed, the first construct that I'm going to have inside of it is going to be a table row. So we're going to start with a new string. So I'm going to just say table row. And if I was doing HTML, I would just have that tag on one line by itself. So that's what I'm doing here. Okay. You could put them all on the same line, but I think that it's easier to get confused that way. So now I'm going to go ahead and create a table data cell. Actually, what I would do is if I was really coding HTML, I always tell people for every tag you open, close it right away, so you don't forget to close it later. Because what happens if you don't? You forget to do it. And that's actually going to be the end of a row, so I'll put the semicolon there. And then I'm just going to continue now by putting the table data cells inside here. But if you look at what the book is describing, the first row just has text in it. You can mark at the end of the line. And then I'm going to do another table data cell. And this one will be the factorial. Just like this. Once again, I'm going to concatenate, and then we're closing the row in the next line. Okay? The next part of this involves each time we want a different row of output, we are going to want to put, basically we're going to be repeating this code. Is really every time we want a different row of output, we're going to create a table row with two table data cells. So that's going to happen no matter what. However, in the process of it all, we have to actually compute the factorial. So in the first position, when we replicate this, here we'll put in whatever the number is that we're computing, and then the next one will be the actual call to the method to actually do the math. So watch how I do this. I'm going to go ahead and start a loop because this is a repetitive process, and I'm going to say for, and I need a loop control variable here, so I'm going to create I, preset it to 0, so that's going to be our index variable, and then how many times are they running this? 10 times. 10.
Yeah, 10 times.
The first row we already created.
Right. Oh, right.
Oh, I see what you're saying, Nathan. So we're running at 11 because we're going from 0 to 10, right? So you're actually counting. So how would I express that in terms of a for loop? I would say is I less than or equal to 10, because then it'll include 10. And then we will increment I. We'll do an I++. We will need curly brackets here because there's going to be more than one line. Right. So for each time we run this, I want to, whatever HTML that we're going to generate here, so there's going to be an HTML generation, we want to feed that into the variable that we already created. We just want to add it to S. And the way that you're going to do that is you're just going to say S plus equals, that's the append. Yes, you can do that with concatenation too. And then we're just going to do, once again, our table row. You can see it keeps, forgetting the brackets here, which isn't good. Pretty much. And then we're going to just keep going. So S will once again plus equal, and this time we will do a table data cell. However, now we want to inject Java code because we want to inject whatever the number is that we're going through. The loop's going to generate that automatically. So now I have to close that quote, concatenate to it the number, then concatenate to it back again the closing table data cell, like so. And then, of course, a semicolon to end the line. On the next line is where the magic happens, where we actually do the math. So once again, we are going to do this approach. And I'm just going to copy the rest of this line and then replace the I. And what we're going to do here is we're going to actually call the method we have below, the compute method. So I'm just going to call compute, and I'm going to pass to it I. So if you're wondering how we do that each time, so the loop is going to send 11 values to that function. And for each one of those 11 values, this will recursively keep calling itself, right? Until it gets to 0 and then stops. So this is kind of weird. So you have to, one of the other reasons you have the 0 in there with the return of 1 is to get it to stop. But this is the magic part, really. But we're also throwing a loop in, so if that's kind of bending your mind a little bit, that's okay. All right, finally, we're going to need to close that row. So we're going to end this by just doing a closing TR, table row. And then we're done with the loop. The last thing we need to do is close the table, so we'll append to the string variable just the closing table tag. And I got to make sure I get that slash in there, and then a semicolon at the end. And then when that's all done, whatever S has put together, we need to return. So we're just going to return S, and inside of S is all the HTML that we've generated. See the beauty of this? Yeah. Yeah, that's cool. I really think that's a clever technique. And you know what? This is a very common technique. So when you're running back-end code to create HTML like this, you want to make sure that you're sending it back in the form of a variable, and then that one variable will contain all the HTML that we're feeding back to the page. And that's a really common way to do it. So very often, regardless of how complex the page is that you're, where you're building this stuff, the code can be very complicated or it can be very simple, but ultimately you are generating HTML that's going to feed back to the page. It's easiest to return it by just sending one variable back. In some cases you'll do little snippets, but for the most part you're usually sending back a block of data, and whatever logic you have to use to get it to go. Fantastic. All right. So let's go ahead and just save this file. Our work here, believe it or not, is actually done. So we have all this code created now. Once again, going back to the HTML page, now we can come back and change how we're calling it and pulling back the response. If you guys remember the technique here, you use the hashtag or a pound sign. Then a set of curlies, and then inside there we're going to call the external class and method. So we're going to call compute Factorial dot response. And we talked about this in the past and how to accomplish it, and how we could also use the actual method name, get response with the parentheses. That's all valid, but this is the way we're doing it here, and I think the author prefers, frankly, that you do it this way, and I think this is probably the best practice. Okay, so now that that's done, let's go ahead and do a Control S to save. But what we're saying here is that the output text that's going to the table, whatever the stuff we're sending back, and this doesn't create the table, folks. This is just a way that we can capture the string that's coming back from the application or from the code, right? So it's the only thing is output text, all right? And then what that value of that text is will come back like this. So this will send all that HTML back in one spot. The only HTML we're creating locally is this H2.
Right.
All right, so can you add CSS to it? Can you do other stuff? Sure, if you want, go ahead, I don't care. As far as I'm concerned, that's not really the important thing here. I figure that you guys can, CSS it to death if you want, but that's not totally not a necessity. All right, let's be brave and go ahead and run this. I'm gonna make sure that I have a browser selected I actually want to use, like Chrome. instead of Internet Explorer. And then I'm going to go ahead and hit the Run button. This, of course, is going to fire up Glassfish for us. It's doing the compile right now. So it's compiling our code on the back end. Build was successful. It is loading up in the browser. You see how fast it was on this, right? It went pretty quick. And then what you should do, and what I strongly recommend that you do, frankly, is you might want to take that factorial table and compare it to either what's in the book or what's out on that Wikipedia page that I show you, just to make sure that the values are right. Did it do the math correctly? It absolutely did. All right. Yeah, not too bad. If you're curious, it's not a bad idea whenever you use back-end code to create front-end code to do a right-click view source and see what it's actually generating. That is not very pretty, right? So for as clever as we thought we were being in the Java file, we weren't really being that clever in the output file. So I just want to make a little point here. The one thing that you could do if you want to format your HTML output to look nice is you can go back to that Java file and put in \n to create a new line and actually force a new line character in too. If you want. That's if you want your HTML to look nice if somebody looks at it like this. I would say at this point that's a little bit overachieving, but if you're curious about how you would do it, that's the how, right? And just for example, you would just come in here, and for everywhere that you wanted it to actually create a new line, you would also throw in /n, like that. And so each one of these, where symbolically it's a new line, I would just come in and go /n, and it would put everything on a different line, and then it would look like what you would type in your HTML editor, and you call it a day. All right, so that was exercise 39.1. Now let's move on to the other one, because this one is a little bit more involved. And my anticipation is it'll probably take the rest of the evening, so we'll see if I'm correct. All right, so we're moving on to 39.9. Now this one, like I said, if you're working on this particular exercise, it is helpful if you go ahead and follow the end of chapter example for building the student registration form, because some of the techniques are really, really similar. But here we're going to ramp up our efforts by not only doing an HTML form that interacts with the back-end page, but also have that interact with our database on top of it all. So it is going to be critical that you guys have your database created. So like the exercises that we were doing in our database chapter, we can tie directly into that same database, but I might suggest pretty strongly that you maybe in a separate browser tab double check your database structure and that it's accessible. So what I'm going to do here is I'm going to log into the database on Apollo using phpMyAdmin, and you can just type in this URL. You do have to have a database account, and I can't assume that you're doing the work for this chapter without having done the previous chapter. So I'm assuming you already have a database, but by some mysterious freak of nature or whatever, you don't. Then I would ask you to go back to the previous unit folder and follow the instructions on creating the database table and all that stuff. But I'm assuming that's all done. Worst case scenarios, you can actually connect to my tables to do the work, and some students do opt to do that just because it's already working, and I'm not faulting you for that. But this is the database that we're going to be connecting to, the one that's called Java Book, and the table we're going to be connecting to is the staff table. So I'm actually going to click on it, and I just want to make sure that oh, look, Nathan, your name is already in there. I must have been picking on you somehow. Yeah. But you can see from here, if I click on the structure tab, what all my field names are, the data types that they are, that I do have a primary key created, etc. So I'm going to leave this open just so that we can refer to it just in case. Because sometimes I'll refer to table column names and forget what they actually are, so I'll bounce back. So that's going to stay open in the background here. All right. So let's read what it says for instructions. It says, access and update a staff table. Write a JSF program that views, inserts, and updates staff information stored in a database as shown in 39.35. All right, so it says the View button displays a record with a specified ID, and the staff table is created as follows. And this is a little confusing because they give you all the fields of the table, but then they like throw images in, and then the rest of it is continued like down here. So you see how they're doing all the examples. But in terms of what we're creating in terms of a front end is basically what you're going to see on the screen here. So on the HTML side, we're going to use those H prefix tags to create this form. And if you look at it carefully, it's almost identical to the student registration form. So we kind of are most of the way there already. And in fact, what a lot of students end up doing is they go to that file in the book, either the sample file or the one they did from doing the samples, and then just copy it over. I am going to be creating it from scratch because it's just about as fast, honestly, and then I can explain it all over. But then the database fields, once again, are all of these. So they start up here, right, and they give this. Now, remember, if you created that Java book database, that stuff's all already there. Okay. So we don't have to do any database work, hypothetically. All right, let's go ahead and do some NetBeans work then. And we're going to begin by creating a brand new project. So I'm going to come up here to the new project icon. Once again, we're going to choose Java Web and Web Application, just like we did in the previous exercise. Next thing we have to do is we figure out what we're going to call this. So I'm going to call this exercise 39_9. All right, so we go into my 2019 fall folder. That's fine. Once again, Glassfish and the latest version of Java EE Web. Leave the context path alone. Click Next. Come here and select Java Server Faces. And then click Finish. It's going to build out our project structure for us. We'll give it a second to do that. All right. So there's our HTML page, folks. We're going to begin by working on the interface. And this is kind of a weird thing when you do any sort of like development work that has a GUI interface. And whether you're thinking of the web as a GUI interface or not, it absolutely is. So we're going to start by building that interface first. It is not particularly fancy, but we are going to follow the same method that or approach that they used in the book. So I'm going to actually start by changing this little piece here. And I'm going to say, what are we going to call this? Staff information, or staff database. Something like that. Yeah, sounds more professional, right? All right. Now we're going to start building out our stuff here. Now, the author, when he puts in the heading for this document, so if you look at like the sample of what we're building, this is our target. And he does have a heading for the table. He or she.
No, I'm saying should it be just like a normal paragraph thing?
It could be whatever, but I'm going to show you what the author's doing. The author's doing this. I'm just going to copy it over. And I think this is kind of interesting when you look at what he's doing. And he's putting this in there. Right. And so when I would run this, what do you think this would generate? Maybe an H1 or H2 or something like that.
Whatever H is.
Right.
Yeah.
So I mean, this is not going to create or contain any programmatic content, so we're not feeding any code into it. So if you wanted to use regular HTML here, hey, go for it. Doesn't matter. But I'm using the H tag just like the author did. I'm then going to include a line break, and you got to remember with XHTML I have to put the closing slash in there. A little awkward, but hey, it is what it is. The next thing that we're going to do is use the H prefix again, and this time we're going to create a form. Yeah, IntelliSense is being not very intelligent here, but it is at least it's operating, and it puts in the closing tag right away. So I went with it and I just moved it out of the way. Now, if you remember how we did the work on the other pages, we use these tags here, and I'm going to do some of them manually, and then I'm probably going to switch to doing copy-paste, just so you know. We started out by, basically for each line we create what we call a panel grid, and then declare how many columns that we're going to have inside here. And so I'm going to declare 2 columns for the first line. And why am I declaring 2 columns? Because if you look at the example, and yes, it wants a closing tag, so let's create it. It's because there's the ID and the box, so those are 2 items. Okay. So now we have to create an output label that says ID. And then we also have to create input text, or that's the name that they use in this framework here. So we're going to choose input text, and then we are going to put in a value, but I'm not quite sure what that value is going to be yet. All right, I haven't built the external file, but I'm going to tell you what, I've decided in advance that I know what I'm going to call it. Here's what I'm going to call it. I'm going to call it staff. So I'm going to put in a hashtag, my curlies, and so that external application or class I'm going to call staff. And then what do I want to come back to the ID text box? How about the ID? So what I'm going to do in the other file is I'm going to instantiate from the database, and this is how these applications work, is we connect to the database, read in the data, and we instantiate it as an object inside of Java that we can then get and set the values for, right? So if I want to feed in an ID here, I could type something like get ID parens, right? Because I'd probably have a get and a set for ID. But since I know that I'm going to do that, I'm just going to call it ID because I know that that's automatically going to do a get. Right. So I'm going to follow that pattern then for all of the fields and labels that we have. And so I'm going to do this in increments of pasting because I do want to kind of save time. So the next row, if you look at it, has last name, a box, first name, a box, middle initial, a box. That's 6 columns, right? And then each one of those will have a label and then an input text with value just like the way that we saw it. So here's the next section of the code right there. So if you want to just take a look. So another panel grid, 6 columns, an output label last name, input text for last name. And notice how each of these are getting their own unique ID. And notice that they are following what I would consider kind of like the modern convention is be really verbose with the names. It not only is the ID the last name, but it's the last name input text because that's really what it is. And then for the value, once again, we'll call our external file, not created yet, I get that, and we're going to be getting the last name. Same thing for first name, same thing for middle initial. All of that goes into one panel grid. The next row, and I'll pop right back, I promise, just has the address and a box for it, so that's just 2 columns. So let's grab that code and drop it in. All right, 2 columns, output label for address, and then input text with an ID of address. Now I think it's kind of interesting here that they were really verbose with these names, which I like, and then totally not verbose with this one. All right? All right. Oh well. You want to make it more verbose? It's on you. Why would you even care? Well, really it's a good idea for anything that you're going to interact with programmatically to always have a unique ID, because that way you can CSS it, you can JavaScript it, etc., etc. So let's not worry about that too much. In the next row, we have 1, 2, 3, 4 columns. So city and state. I would argue we're zip, but not too worried about it. So let's grab this. We have 4 columns. City label, city input text, state label, state input text. Same convention for calling the external program and getting the data from the object that we'll be instantiating externally. I know this is a lot to type, so if you're watching this video or perhaps sitting in the classroom copying the code, I'm trying to be kind here. And I get people with all sorts of strategies, like people watching videos. This is a great time to pause and do a screen capture and type in all this code. The one thing that I also do is when the programs get really, really long, is at the very end of the video, I'll scroll through everything once, like one page at a time, and you'll get the complete code at the end. All right. Let's go back and take a look again at what we're building. So next is, okay, we got city, state, and telephone. And that seems like 4 to me, 4 columns to me. We'll go ahead and grab the next block of code. No, I'm sorry, that's 2 columns, right? Just telephone and a box for it. Now, I don't know if you guys are picking up on this, and maybe you are, but here, first, I'm going to do a Control S to save so I don't lose all the work I've done so far, because it's, you know, quite a bit of code I've thrown in there. I'm going to go back real quick, and I want to take a look at my database, because something in my database is tickling the back of my head saying, hey, wait, there's an email field also. Maybe we should throw that in. You guys cool with that? You know, I don't have pre-created code for that, so you know, here's what I'm going to do, is I'm going to go ahead and repaste the telephone code, but I'm going to change it to email. Right, and did they like start out with a colon? See, like up here they started with a colon. See that? and then they didn't follow suit. Okay, well, you know what? Let's throw colons in there. You know, I might even go as far as like doing this, like throwing a space in too. Am I throwing off your mojo here or something? That's all right. You'll be fine. You'll live. What I always tell students is, like, don't worry so much about formatting it perfectly right away first. Get it to work, and then you can then you can do whatever the heck you want. Yeah. Celebrate. All right. So we got another row in there for email now. All right. Next thing that we have to put on the screen are the 4 buttons at the bottom. So we got to put view, insert, update, and clear. And those are buttons that we're going to allow, once again, the interface or Java to kind of create dynamically for us using their shortcut code. There were 4 buttons, so I'm going to need 4 columns in the panel grid. So I'm doing it like this. So I have one for view, insert, update, and clear. Do you notice which one of the CRUD actions is missing? Yeah. Well, the CRUD, what does CRUD stand for? Create, retrieve, update, and delete or destroy. One or the other. And that's not here. Clear is just going to empty the form fields. We don't have one. So if we wanted to ramp the application up after we get it to work, we could add a delete. So we could actually set it to delete a record right from a web browser. That's kind of cool. All right. The last thing I'm going to add at the bottom here is this. If something happens in the program, okay, I want you to conceptualize this. If we go and use the interface and we do a search for a student ID or a staff ID and it doesn't find it, what happens? Nothing? Or how about if we do something and it does happen and it works? I'm going to actually create one more panel grid at the bottom just to contain output messages for the user, so we can say, hey, your insert worked, or database information not found, or hey, well, how about this? If the database doesn't connect, we should put a message on the screen saying, sorry, database is not connected. Don't forget to try VPN, right? So those of you listening at home, the real key thing here is if you're trying to connect to that database, your application needs to have a VPN connection back to campus to connect. And that's probably going to be the number one problem when working from home, is getting that VPN client working. Now, while we are talking about that, I actually created a new set of VPN instructions that I don't think I've loaded up to most of my courses. I think the only one I put it into is my orientation class. But I assume that most of you at this point are already using a VPN, because you wouldn't have been able to do the stuff in the previous chapter otherwise. So I'm just taking this guess that you already have that in place. All right, so here's the very bottom part of the code, and our HTML page is basically done. So I'm just going to go ahead and do a Control-S to save it. All right, we're at halfway through the class right now, folks, so I'm actually going to pause the video, and we're going to take 5, and I'll try to get as much of this code on the screen as I can, you know, assuming that you got most of the stuff above it. So let's take 5 minutes, and we'll come back and keep working. All right, we're back from break, and we're going to continue forward here. So we have our HTML file in place, and it's pretty much set to go. What we need to do next is actually create the Java code that goes with all of this. So we're working on exercise 39.9 here, and I'm going to go ahead and right-click on the project node and create a new managed bean. I'm going to go ahead and call this staff. Oops, and I'm typing in the wrong. I'm typing on my other screen. That's not good. All right, here we go. Staff. And you know what? What are we going to call the package here? What did I forget what I called the last one. Let's just call it x39_9. That's fine. Now, the other stipulation here is we're kind of stepping up a level here, all right?
Yeah,
because that's the question. Because in the previous ones, really we were just requesting information to come back.
Yeah.
And if you guys had followed the student registration example in the book, you'll realize that since we're interacting back and forth, so we're sending stuff and receiving stuff back, we're really working on an application level. So we are going to be application scoped. So the information's going in both directions. And really that's what we're building here, is an application with a database on the back end. So that's our choice. I'm going to go ahead and click finish, and you can see it built out the code for me. I am going to kind of save on a little screen space here like I did the last time. Not that I really need to do this, but I just want to get as much stuff on the screen as I can, partially for your sake. So I got that stuff kind of squeezed in at the top. I'm also going to get this stuff out of the way here. Now we need to think and talk a little bit. When we did the factorial thing, we didn't need to instantiate an object because we were just calling the thing and it was running some math and sending back a response. It was just really just returning a string. Here it's a little different. We are actually going to use the constructor function to instantiate data. So in other words, when we launch or call this, it will connect to the database, pull back data, and every time we do that, it's going to create it as an object in memory. So any record that I retrieve from the database is coming back as an object. right? Since it's coming back as an object, it's going to carry with it all the different fields that are embedded into my database. So it's going to come back with ID, last name, first name, middle initial, address, city, state, telephone, and email. All that stuff is going to be sent back. And then, if it's coming back, I need a place to put it. All right? So before I even build the constructor, I got to actually think ahead a little bit. And what I'm going to do is I'm going to create a string variable that's going to hold each one of those things. Now, I could go ahead and just say string ID. I could go string, whatever the next item is. That's highly inefficient. And you know what? Professional programmers just don't do it that way. They do stuff like this. And what I'm copy pasting at this point, but this is what they do. They do a combination declaration and call them all at once. I need all of these string variables. I'm not putting anything into them yet, but I'm creating the container that will hold them. The spot in memory that will hold them has just been created. What's that?
What was the name of that? Combination.
Well, it's just a way of declaring a whole bunch of variables at once. Yeah, I'm not really sure. It's a combination declaration. So instead of going string ID, string last name, string first name, one by one, I'm just going through and just saying, hey, these are all strings, create these please. Thank you. Done. One line of code instead of 10, or whatever it is. All right. Next thing that we're going to do...
Did you want email there as well?
Did I want email there in there as well? You know what? That's a good point, Nathan. Let's do that, because we are thinking about calling that. So I'm putting it here because that's where it makes sense for me to add it. Okay. All right. Now, when we do call the constructor, we want not only the constructor to, well, we got to do a couple things. Let's think about this, right? If we call any methods inside here and we're extracting data from the database and we're going to instantiate that stuff as an object, that's all well and good. But to start with, so the application doesn't crash or give us an exception, I want to pre-populate all of those variables with empty quotes. So the first line number 7 creates the variables, right? But if we interact with them at all and there's nothing in them, we'll get like a null pointer exception or something like that that says, hey, you don't have any stuff in here, what are you trying to do? Are you an idiot? Right, basically. This is what the compiler is going to say. So the first thing I'm going to do in the constructor, and this is another clever little trick that I learned a long time ago, and this is another shortcut a lot of pros use. And that's why I like to show it to you. So I'm going to set ID equal to last name, equal to first name, equal to middle initial, equal to... And you got to remember how assignment statements go. It's the item on the right is populating the item on the left. And if you go all the way to the end of the string, what I'm doing is I'm making status empty, right? And since that one's empty, telephone, state, city, they're all empty. Once again, instead of 10 lines of code, 1 line of code. The only thing I'm going to add, of course, is email, because we forgot to do that. Talk about a shortcut, right? The other thing that I'm going to do is, so I've got my variables created, I've set them all to an empty string. And that way, at least if I call something and it doesn't find something, it sends back an empty string, it doesn't crash the application.
Nice.
Right.
Okay.
But the other part of calling the constructor is to actually make the database connection. So what I usually do is I create a little method, and this one I'm just going to call initDB. And this is a method that has not been created yet. So yes, NetBeans is squawking about it. But that is what's going to happen each time I do it. So you know what? We better start doing our database work then, right? You betcha, we better. All right, so let's go ahead and start creating this. And let's see if NetBeans will do what some other IDEs do. And I'm trying to get it to give me code hints here. Okay, it says Alt-Enter. Let's see if that works. So notice it says create method initDB. Okay, I can do that. Boom, done.
What?
Yeah, that's pretty cool. I'm going to actually get rid of this exception right here. Frankly, we just don't need it because I'm going to use a different approach. It puts that in there preemptively if it doesn't know if you're interacting with an external data source so that your application doesn't crash. But here's what I'm going to do, is I'm going to set up a try-catch. So the reason I'm doing this is to allow for the application to carry on if there's a failure in interacting with the database. You don't want your application to quit just because a database connection isn't made. So I'm just setting up a try-catch structure here, and then I'm going to start putting my code in. All right. So what code am I going to put in this place? The same database connection code we used in the previous chapter, folks. Right? All the same, the connector, the maybe certain query statements or whatever. We're going to put it all inside of this method here to get that going. So I'm going to begin with the same statements that we used from the last chapter, which are these. So I'm pasting them in. So I'm calling the JDBC driver for MySQL. The other thing I'm doing is I'm doing a console output, and I'm saying driver loaded. In fact, I might even say like my SQL. You can be as verbose as you want. This is going to write to the console. Users will never see it, but it will write to the server log. All right. Next step is to get the connection going. Once again, using the same connection string that we used in our previous application. Now you do see that it's underlining red and squawking for libraries, right? So let's see what the fix is. Alt-Enter. Add import for Java SQL connection. Sounds good. Right. Didn't have to think about that a lot, right? In fact, here's what I'm going to recommend. Now, I don't normally do this because every time I do a database thing, it's going to want to add each individual library, and it's, frankly, it is an efficient way to do things. But I'm going to come up here to this statement. I'm just going to change this to an asterisk, the wildcard, up here in the import, and that way I don't have to worry about any more connection stuff. It's just all going to work automatically. And that way, let's say I was to ramp up this application and add other features to it I don't already have. I don't have to think about adding the libraries. They're all just going to be there. I would get a lot of argument from professional developers who say that's really inefficient. You're loading all the things you don't need to. Oh well. It's not that big of a deal. Just go with it. Down here, you're going to see in the connection string the call to the MySQL server on Apollo, the database under my account with my username and password. If you are having problems with your own database, feel free to connect to mine. That's okay. I would prefer that you connect to your own, though, and I might remove a little bit of points if you don't connect to your own, because really you should have your own running at this point. But if you're having issues, you can always throw my connection string in to see if it works. And if it's working with mine and not with yours, well, then we got to figure it out. Right. Once again, I'm going to output to the console that we're connected. So if it makes that connection, message is in the console. Wonderful. Now we have to think a little bit before we type our next statements. There's a bunch of different things that could happen. So the first thing that pops into my brain is this. All right, so I put in the driver, I get the connection to the database. What if those things fail? Well, the catch statement is going to catch the exception, and then you can output that extension to the screen for the user if you want by doing this. And then they're going to get some really cryptic, like database thing or whatever, you know, like what Java debug errors look like, right? The user's going to see that. You really want them to see that? I'm gonna tell you what. If that's what you want to do, go for it. My thinking is, no user really cares. All they really care is it's not working. So that thing that we created in this form down here, the status field, that's below the whole form, I'm actually going to populate that here. So I'm going to actually put in a status message. And what I'm going to do is just basically take that status variable I created above, and this is what I said last time. There's a problem with the database, please try again. And this is basically just a string put in a variable that I'm going to feed back to the main application. See how that goes? And they'll see it on the screen. And that's much more useful than a Java debug stack trace. Trust me. All right, so that hopefully will help with that little piece.
What did you do when the connection was underlined?
Which thing?
Connection to the driver manager. So you right click it. Or control space.
Oh, with this environment, it's Alt Enter. Yeah, and I always forget that with NetBeans.
Okay. And is it a SQL connection?
Yes,
Yeah.
but then the little caveat that I did, Nathan, is I changed it up here with the wildcard, so I got rid of connection and just put in an asterisk to just pull it all in.
I always right click. You can?
Yeah, you can right click too. That works. Yeah, that works too. And I'm glad you mentioned that. All right, so here's more food for thought here. When we do the next step, some of the stuff that we're going to do, frankly, is going to be repetitive. Okay, so let me explain. In other words, if I'm going to do a query to view information in the database, that's always going to be the same. The only variable in it is going to be, we're going to call it by looking at the ID number. Now, if I was building a really robust application, I might set it up so I could search on last name and on phone number, you know, like all these different, but we're deciding to just look up on ID. So what I want to make you think here is every time that I look at information in the database based on an ID, the query will always be identical with the exception of the ID. So here's what I'm going to do. Right inside the database initialization is I'm going to preset a query. All right, so let me just show you, for example. So I'm going to declare a string variable, and what it's going to hold is my query in plain text. So I'm going to just type query for view. Okay. And then here, I'm going to start typing piece by piece what that query is going to look like. Now, there's a whole bunch of issues that are going to pop up here, and I'm prepared to handle them one at a time, but I'm just trying to think ahead. So if I'm doing a query to look at a database entry, if you guys remember your SQL statements, you can type a select statement, and I'm going to select what? Given that I already know the ID, I'm going to select last name, assuming I typed that correctly. And here's the catch. Up here, oh yeah, I did name it camel case, that's great. But really what I want to type here is not what my variable names are. They might be the same. Really what I'm typing is what's in the database. So whatever this is, that's the one I have to match. It's got to be exact case, perfect, It cannot stray. I'm also going to pull last name, we'll do first name. In fact, at this point, I think I'm probably going to drop down to the next line, so let's just do a concatenate, and then I'll do middle initial, address, city, state, telephone, email, right? And what table are we taking this from?
Staff.
From staff. And you know what? I better check the name of staff too. Capital S. Okay, I'm glad I checked because I was going to type lowercase. From staff. Not quite done yet. Real close, but not quite. I'm going to actually put a space here. And don't forget to do that. That's one of those things that can break it.
Really?
Yeah. Because if I add another line down here and there's no space in between, it sees it all as one thing. Yeah, it
It'll be
doesn't.
one word.
Yeah, not. Believe me, not good. And what's our search criteria? Where?
ID?
Yeah, and ID is lowercase, I think, in the table. Yep, lowercase. Where ID equals question mark. Yeah, you.
Question, could you do an or and keep going?
I could do a whole bunch of stuff here. Yes, I could. All right. But Vaughn, just to clarify, this is the way I'm choosing to do it. All right. And the way that I do it, and this is something I've done for a long time. I'm happy to see the author thinks the same way as me, as I kind of separate out all the actions, and I think this is a nice, simple way to approach it. All right. So if you're now going to execute that query, now you have to do what they call a prepared statement. Okay? Now, I know that's going to require a library, but I also know that it's going to require a variable. So here's what I'm about to do, and it's a special data type in Java specifically designed for retrieving queries. So like we have a string, right? This accepts database objects that are pre-prepared, okay? So I'm going to create up here on the global level a prepared statement like this. And notice I'm creating one for view, one for insert, and one for update. So I'm being a little preemptive. But in order to execute this query, I do have to first make sure that that's up there so that I can feed it in. So now since I'm going to be operating the view query, and I'm trying to find my mouse here. Oh, there it is. Okay. It's weird how it's right in front of your face, but you can't see it. And so right here, I'm going to paste in this statement. And really I want to put a line in between them. I mean, that's how I prefer to see it. So we're going to use our connection, database connection. We're going to use the database container object thing. I don't know really what the proper name for it is. And then we're going to send to it the query for view. So here's the methodology, folks. When I want to do a view on the database, all I have to do is call PS view. It contains the connection, the database connection object thing, like I'm not sure what to call it, with the pre-configured query by just using one little variable name. See the power of that?
Yeah.
I could alternately, instead of just calling PS view other places in my code, I could rewrite the query every time. Makes no sense. And because this is a global variable, that's why I put it up top. It's a global variable. It's pre-declared in the initialization and then is ready to go whenever you call it. That's the thinking, right? Okay, I will hear from students that couldn't I make the query string global? And yeah, you could do it all sorts of ways. And you know what? Then you can get into a whole argument about what's better and more efficient and more logical, whatever. And frankly, I really don't care. But this works. And what I like about it is inside of a private method, so it's only accessible inside, this part of the application. But what we are creating, in essence, with the combination of the query and the connection string thing, is we're putting it into a variable name that we can use one word to control the whole application. Now, since I've done the query for view, I'm also going to do a query for insert and update. Exactly. So here's insert. And let me ask you guys, I know some of you have had the database class and some of you have not, and I understand that. Ideally, like if you're a full-time student, you're taking databases at the same time you're taking this course, because you really kind of need some database knowledge. But what happens in databases when you use a question mark? What the heck is the question mark for? Okay. Let me ask you this then. What is this for? The little
Wild card.
yeah, it's a wild. There you go, folks. It's a wild card. It's waiting for data. That's how you do it with SQL. Isn't that cool? So SQL uses a question mark for a wild card. And okay, so that's our query for insert. So if we're going to insert something into the staff table, here's the SQL statement is insert into staff, and then inside parentheses, in the order that we want to, and ideally, and this is where you have to be careful, because you can actually alter this order, but it's not really recommended. But we're setting it up in the order that it's listed in the database. And you know what? I'm noticing once again, yeah, email's missing. And then if I'm adding email, the second aspect here is, so into these columns in the database and in this order, we are going to insert these values. And so I have to have the same number of question marks here as I have variable names or column names. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. And here I got 1, 2, 3, 4, 5, 6, 7, 8. That will throw an exception right there. So that's got to be one more question mark. So you think about this. If I'm creating a new record, so I'm starting with a clear form, and I type in all the fields, it's going to grab the stuff from the front end form, and then in the order that this list displays it, it will feed it to the database. So these values will go in that order, and then they'll populate the database directly and write the record. Really powerful, right? Question mark is the wild card. The next thing we do, of course, is we're going to have a prepared statement that goes with that. So let's call that one PS insert. So once again, every time we do an insert statement, we just use that keyword PS insert, and it does the connection, feeds the query statement in, and it's all right there. One variable call. We do also need to do update. So here is the query for update. So we're pasting in our query string for update. And once again, we're using the same information. So the command for SQL is update staff. And this is a little bit different. And it says set each one individually. So you notice how they do whatever the field name is equals question mark with a wildcard. So if we just change the last name, it's only the last name that will change. If we just change the email address, it's just the email address. Oh my God, where is the email address? Let's add it in. So email equals question mark, and then we need a comma after that. Do we? No. If I put a comma in, it thinks I'm throwing another statement in there. If I don't, it considers the statement done. All right, once again, that's also going to get a prepared statement stored in the variable, like so. And with that, folks, our init database method is complete. Right? And this is probably a little bit more involved. Like some people will actually instead of doing it this way, we'll take these prepared statements and put them in a separate method. You know, there's all different ways to approach it, but this is just one way. I think it's a pretty efficient way. And for most of the application building that you would ever do, this is enough. All right. All right, that should be good. We haven't saved for a while, so Control S to save. We've typed a lot of code. You do not want to lose your work. Absolutely not. All right, so now we get to the challenging part of this. If you thought that this part was challenging, no, that was the easy part. Not to freak you out, but yeah. Now we get to the challenging part. Now we got to build all the methods that actually work with the buttons. So every time a person hits a button, now if you go back to our HTML form, we kind of pre-planned this a little bit actually. So for each one of the buttons, if you think back to when we were just doing, you know, regular GUI programming in Java FX, right? We would create buttons, and then every time we hit the button, we'd get a little lambda expression in there, and it would trigger a method that would do whatever. Same thing here, and that's why we have it called View, Insert, Update, and Clear. We're going to create all those methods. All right. My favorite way of working on this stuff is let's do the easiest thing first. What's the easiest thing first? And I just thought of something I totally forgot to do.
Clear.
Yeah, clear is the easiest one to do first. All right, but I just thought of something else I forgot to do. And I'm going to see if you guys can think of it for a sec. Okay, so I'm restarting the video now, so I posed the question to the class. And what I was pointing out is the fact that we are building a class that actually has a constructor function. And also, at the very top of, you know, outside of the constructor in the class, we also have some global variables, which is, you know, the pattern that you use when you create a class that you use to instantiate objects. Meaning that all of these variables up here really need getters and setters. So now the question is, how do we do that in NetBeans? I know that I could go in there and manually type each one out for sure, right? And then I hope that you guys learn the trick in Eclipse where you right click and you just generate them automatically. So the question is, how do I do it in NetBeans? Is there a right click for it? The insert button. Yeah, Alt and insert. And see how it says right here, insert code? So I'm going to click that, and then it just brings up this little menu. What do I want to do? Oh, getters and setters. And you know what? I'm going to let it do it. Which ones? How about all of them? Sounds good. Yeah, it is pretty nice. So I'm going to just click generate. The problem is to put them at the top of my program, and I hate that when I have a program like this. That's not the stuff I want to see at the top. It even created getters and setters for the stuff up at the top, the prepared statements. Or no, it didn't actually. I was hoping it didn't because I didn't highlight those. But I'm going to take all these getters and setters, or actually it did, didn't it?
Yep.
Yeah. I'm going to cut and paste them and put them at the bottom. You know what? Those getters and setters in particular don't really matter so much. Just make sure they're global, so they're not inside the initDB or the staff thing, but they are inside that closing one. And I'm just putting it at the bottom because you know what? Way at the bottom is fine. It still works. Right? Just get them out of the way. Okay, getters and setters for everything. It's all done automatically. It's perfect. It's beautiful. I didn't have to hand code it. That just saved me like 50 lines of typing, right?
Yeah.
And more importantly, no mistakes. And that's really the more key part to me.
Yeah.
You know, and that's what pros do. Pros will not type that stuff out. Why on earth would you?
Yeah.
When you can right click and just do it like that. All right. So now that that piece is done, let's do the clear method, since we've already determined that that's the easiest one. So I'm going to go ahead and create that. In fact, I already have it created, so let's just paste it in. So here's my clear method. So it's a public void clear. It's a void because I'm not sending anything back. All I'm doing is clearing the form fields. And then I'm going to put a status message up here, right? And I'll say form is cleared. Okay. And notice what trick I used again. Setting them all to an empty string like that. So you can copy that one from up above if you want, or I guess you could laboriously type it if you prefer. That's up to you. Piece of cake. 1 down, 2 to go. Unfortunately, the other ones aren't quite as simple, so we have a little bit more work to do here. Let's go ahead and first work on view. All right? And I'm looking at the clock, and I'm kind of realizing I hope we can get done in time now. All right, so I'm going to go ahead and just start typing here, folks. So I'm going to begin by typing this manually. So I'm going to create a public void view empty parens. Okay. The one thing that I'm going to do, just for my own sake, if I'm going to view something in the database, I'm going to go to that form, type a number in the ID field, and click the view button. That's how it's going to operate. Right? For my own sake, so I remember which one is working or not, I'm actually going to write a message to the console just so I remember which record I'm working with. And in the past I've done this. I just do a system out print line and put the ID number out there. If you wanted to be more verbose, you could say the current record is concatenate it, and whatever works for you. Users are never going to see it. It's for your sake, not theirs. All right. The next thing we're going to do is we're going to realize that we are interacting with the database, and because we don't want to crash, once again, we are going to set up a try catch. So I'm going to begin by defining a try, and then a catch. And I'm setting that up right away just to get it out of the way. I will need to put in some exception handling here, but I'm going to come back in a moment. So I'm just going to, inside here, I'm going to do this. I'm just going to type SQL exception, because what's going to generate the exception, if anything, is going to be that database interaction. Then I set up a variable to receive the message. What I did last time, now you see, now what am I missing here? A SQL exception is never thrown in the body of a corresponding try statement. Oh. What it's saying is it's not part of the same structure. Ha. Got it? Not that you guys care. All right. I'm going to actually, let's do this. I'm going to comment this out right now and come back to it. Not ignoring it, just commenting it out. We'll come back to it. Now what this is going to say is, hey, you don't have a catch.
Yep.
All right, let's get rid of the comments
There's
then.
no winning.
Yeah, absolutely not. All right, I'm just going to keep typing. I'm ignoring the error for right now. Okay, so we want to work on the view. You know what the beautiful part of this is, folks? I've already created the query. All I have to do is call it. So I just say PS view. So you see how beautiful that is?
Yeah.
Query's already done.
No.
Boom, query. But here's the thing. If I'm trying to do this, I'm going to be setting it to a string. So whatever my query is, and I'm going to be sending it somewhere, and I'm setting it based upon the ID. So the search field is the ID. So I'm going to type here this following command, then I'll explain what it means. So I'm going to type set string, and then I'm going to put in a 1. That's an index value, by the way, followed by the name of the field that I'm dealing with. So you see how it typed in ID for me?
Yeah.
I didn't type that in because it realizes from the connection to the database, and actually from this statement is really where it's getting it from. So what it's looking at is at the insert statement, the first item is ID. All right? And so it's just dropped it in automatically.
That's groovy.
Yeah, it is really groovy. All right. Once you run a query, you have to have a place to put it when it comes back. So for that, we have what we call a result set. And that's a special database object that receives it. We'll get the library in a second here. I'm just going to type the command first. I'm going to say equals PS view dot, now we tell it to run the query, execute query, and it will do it. Now you notice how I fixed it, right? It's saying if you got a result set, where's your query? That's really what it was saying. And so now that I do have it set, and then I have a variable that's just to receive the result. All right. The next thing that we do is this. We're going to put in an if statement that's going to automatically find the first, and what the terminology we're going to use is next, actually, first instance of whatever matches. So here's how we're going to do that. So it's saying if the result set's next occurrence is true. So it found something. That's what it's saying. You know, if that okay, give me the next thing you got. Oh, it found one, so that's the next one, right? Then we're going to go ahead and do what? We're going to grab the stuff from the database and put it into the variable. That's what we're doing. So I'm going to put in my curlies and then one field at a time. Now I don't have to do ID because ID has already been typed in. See the logic here?
Yeah.
So I'm going to say last name, my variable, is going to be equivalent to the result sets, whatever string is located in index position 1, which is going to be last name. Okay. Now if you start extrapolating that out, you're going to get something that looks like this. Yes, I'm copy pasting to accelerate here. So you got first name, last name, and you see how the index values just keep climbing up. And those index values are once again based upon the order that we created above. We do need to add one for email. So let's just do email equals rset.getString, and then that will be index value 8.
Why doesn't it start with 0?
Because relative to the result set, 0 is ID. Yeah. Yeah, it doesn't make sense because, Vaughn, that's exactly correct. It doesn't make sense. But if you come here and look at, see this, for the first part, this is the quirkiness of it. When I pull in ID from the database thing, it knows that ID is the first one here. So that's why it used 1. But when it pulls back the result set, it'll start going 0, 1, 2. See? That's how it counts up. So there are really 9 values of 0 to 9 here. That's why it's offset by 1. But when I pull it from the database, that the connection part of it, that starts counting at 1. Don't ask me why, that's just how it does it. Okay? Somebody decided to do it a long time ago, and programmers have had to work around it ever since. And then, you know what? If it successfully does all this work, heck, I'm going to throw the status message up on the screen and say data retrieved. Right? What happens if it does not find the information? Okay, so you got to accommodate for that. This is what I did last time. Is I did a console write. And I said, you know, for myself, the ID number and that record's not found. And then the status field, I did the same thing.